What's up, everybody? Welcome back to the Science Studies Podcast with your host, Nicole Rao. Today, we'll be talking about the beginnings and endings of our universe and our solar system's planetary orbits, moon formation, and other solar system bodies. Joining me today is Breezy Weeks, who has a doctorate in astronomy from Uri University and works for NASA. So, Dr. Weeks, what are the types of galaxies and how do they form?
Hello, Nicole. It's so good to be on the show today. Galaxies are classified by the type of shape they resemble, elliptical, spiral, or irregular. An elliptical galaxy is shaped like a football, small at the ends but big and fat in the center. A spiral galaxy looks like a pinwheel. A good example is our galaxy, the Milky Way. They have bright centers, also called nuclei, that everything else in the solar system is around. An irregular galaxy, just like its name, is irregular. They have no real pattern to them. We can tell that the Milky Way galaxy is a spiral galaxy since we have a star and everything else in our solar system revolves around it.
So, how are scientists able to learn about deep space since the objects are so far away from Earth?
We're able to learn about deep space through parallaxes, which is an apparent shift in position of an object when viewed from different positions. The Doppler effect, which is an apparent change in frequency of a wave caused by the relative motion between the source of the wave and the observer. Astronomers use parallax to measure the distance from different spots on the Earth. They can use the color of stars or other galaxies to determine how far away they are. If they look red, then they are slowly coming towards us, but if they're blue or purple, they're moving away from us.
So, Dr. Weeks, how were the different universes created?
Well, there are two theories that most scientists recognize as valid, the steady-state theory and the Big Bang theory, and we're not talking about a television show here. The other theory is the nebular theory.
So, what's the Big Bang theory about?
The Big Bang theory suggests that at the beginning of time, or scientists call it time zero, there was only energy and it slowly condensed into smaller volumes that caused temperatures to increase. Then, the universe started to expand and the temperatures slowly started to decrease. The most significant piece of evidence supporting the Big Bang theory is something called cosmic background radiation, which is a form of electromagnetic radiation. Astronomers have detected the radiation in all directions of the universe.
Alright, so what's the other theory, the steady-state theory?
The steady-state theory, also known as the infinite universe theory, suggests that the universe didn't have a beginning. It has always been there. The theory suggests that new matter, mainly hydrogen, is continuously being created out of empty space. The rate at which the new matter appears is in balance with the expansion of the universe. Therefore, the average density of the universe remains constant.
Now that we've talked about the steady-state theory and the Big Bang theory, can you explain the nebular theory?
Of course I can. Many scientists believe that our solar system was created from a nebula, a spinning cloud of interstellar gas and dust. They believe that the gravity caused the gas and dust to come together to form the cloud, causing the nebula's rotation to increase. As the nebula's speed increased, it eventually collapsed and formed a disk shape. The matter from the nebula condensed to form planetesimals, which eventually all collided together to create protoplanets. The center of the solar system was formed, which created a strong gravitational force. The cloud at the center of gravitational force eventually reached up to 15 million degrees Celsius. Hydrogen atoms in the cloud of gas and heat formed to create helium in a process called nuclear fusion. The sun's great gravitational pull keeps it together while also providing light and heat to the rest of our solar system. The terrestrial, or inner planets, Mercury, Venus, Earth, and Mars, were formed in the original nebula that formed the sun, where there were higher temperatures. The terrestrial planets are small rocky bodies, and some of them have crusts and mantles. There are also Jovian, or gas planets, which include Jupiter, Saturn, Uranus, and Neptune. They were formed in the cold outer parts of the original nebula and were far away from the sun and covered with mostly gas and liquid forms of hydrogen.
So what will eventually happen to our universe?
Well, that's kind of hard to determine right now, but scientists have three theories. The universe will expand forever, the universe will grow to a certain point, then stop, or the universe will stop expanding and begin to collapse. We're able to figure out which of these three will happen from scientists calculating the distance from our galaxy to other galaxies far away by using the Doppler effect. Through this, we can determine if the universe is continuing to expand and at what rate.
So many of our listeners don't know what Kepler's 3 laws of planetary motion are. Could you explain them and how they apply to space?
Kepler's 3 laws of planetary motion are used to describe the orbits of planets. The first law states that the orbit of each planet around the sun is an ellipse, or oval shape. The second states that as a planet moves around the sun in its orbit, that it covers equal distance in equal time. Finally, the third states that the time it takes for a planet to complete one orbit relates to its average distance from the sun. Ellipses have different properties to determine how they orbit. For example, eccentricity. The orbital eccentricity of a celestial object is the amount by which the orbit deviates from a perfect circle. So, an orbit with an eccentricity of 0 would be much more circular than an ellipse with an eccentricity of 1. The eccentricities of planets can change over time due to the complex effects of weak gravitational pulls from other planets.
So how do most people believe the moon came to be?
There are 4 possibilities on how the moon was created. One is that in the early stages of our Earth, it spun around so quickly that some of its outer layers came off where the Pacific Basin is, and that's what formed the moon. Another is that the Earth and the moon formed at the same time, since they're both around 4.6 billion years old. Another is that our moon formed in another part of the solar system, and the gravitational pull of the Earth caused it to orbit around the Earth. The one that scientists believe is the most plausible is another celestial body about the size of Mars collided with young Earth, creating the moon. Scientists hypothesize that the moon's orbit became so used to the gravitational pull of the Earth that the Earth and the moon stabilize each other as other planetesimal bodies continue to crash into them.
Why does the moon have phases, and what is the moon's size and gravity compared to that of the Earth's?
The moon appears to have phases because the amount of sunlight on the face of the moon changes as the moon continues to orbit Earth. The moon needs around 29.5 days to complete orbit around the Earth, giving us 8 lunar phases. Starting with a new moon, a totally dark sky, then a waxing crescent, a fingernail-shaped moon that starts off on the right side. The first quarter, half of the moon can be seen on the right, while the other side is black. A waxing gibbous, most of the moon can be seen, except for a black crescent shape. The full moon, all of the moon can be seen. A waning gibbous, all of the moon can be seen except for a crescent shape on the right side of the moon. The last quarter, half of the left side of the moon can be seen, and the waning crescent, only a crescent shape on the left side of the moon can be seen.
Why and when do eclipses occur?
There are 2 types of eclipses, the lunar eclipse and the solar eclipse. During a solar eclipse, the moon is in between the sun and the Earth, so it stops a certain amount of light from reaching the Earth. During a lunar eclipse, the Earth is in between the sun and the moon, so the Earth blocks the sunlight from reaching the moon, causing the moon to become dark. These are much more common. Eclipses mostly occur over the ocean, so they're harder to see from land, which is why they're such a big deal when we're able to see them properly.
So why do we have tides?
The pull of the sun and the moon cause the tides on Earth. There are 2 different types of tides, spring and nep. Spring tides occur when the sun, Earth, and moon are aligned horizontally. They cause high tides and normally occur when there's a full moon or a half moon, meaning that spring tides only happen twice a month. Nep tides appear when the sun, moon, and Earth create a 90-degree angle and create low tides. They happen during the first and last quarter moon, so they only occur twice a month as well.
So what is the difference between comets, asteroids, meteors, meteoroids, and meteorites?
Asteroids are space rock and dust, while comets are space dust and ice. In our solar system, there are many asteroids that orbit around the sun in between Mars and Jupiter in a space appropriately named the asteroid belt, but some of them orbit elsewhere. Comets orbit around the sun in the outer solar system. A meteoroid is an object that is flying through our outer space, but is smaller than an asteroid or a comet. A meteor is a meteoroid that has passed through the Earth's atmosphere, and a meteorite is a meteoroid that has passed through the Earth's atmosphere and hit ground.
Well, that's all, folks. Make sure to tune in next week when we'll be talking about tectonic plates. I'm your host, Nicole Rao, and this has been another episode of Science Studies.